Kinematic equations really aren't that hard. You use them to solve for velocity or acceleration or time. See, change of x equals displacement. VO equals initial velocity. VF equals final velocity. A equals acceleration, and T equals time. It's really not that hard, guys. I still don't get it.
I don't either.
Let's go watch the video. Wanna come on?
Velocity is the rate an object is moving, taking into consideration positive and negatives. Positive velocity is either moving up or to the right, and negative velocity is moving either to the left or down. Velocity initial, otherwise known as VO, is the starting velocity of an object. V final, or VF, is the final velocity of an object or the relative ending velocity. Delta x, or change in position, is defined as the change in from a starting point to an ending point. If you have your starting point and ending point be the same thing, the same position, you have no change in position. And it's the difference between the end position and starting position. T equals time, and the unit is seconds. It can be defined as time elapsed during a velocity being studied. Acceleration equals the change of velocity over time. The change of velocity means the changing of the amount of meters an object can travel in 1 second. The change of velocity is set over time to get acceleration, creating the unit meters per second, or meters squared. The acceleration of an object in freefall is negative 9.8 meters per second. If a cart is traveling 4 meters per second and in 4 seconds is now traveling 12 meters per second, how can we find the object acceleration? Okay, this is how we can do it. We can put 12 meters per second subtracted from 4 meters per second, which is the change of velocity, over the total time being 4 seconds. 12 meters per second minus 4 meters per second is 8 meters per second over 4 seconds, which equals 2 meters per second. The kinematic equations are velocity final equals acceleration times time plus initial velocity. Change of position equals 1/2 the quantity of velocity final plus initial velocity times t. Change of position also equals 1/2 acceleration times time squared plus initial velocity times time. Here we have a car going down a hill. And here is the relative position versus time graph and the relative velocity versus time graph. Using the equation and what we know the acceleration to be times the time added to the initial velocity, we can solve for the final velocity. By knowing the area under the curve equaling displacement, and because displacement equals change of position, we can solve for the change of position. We derived the equations by solving for the shaded area under the curve, using equations to solve for the area of squares and triangles. Now combine both derived equations.
When you combine both equations A and B, first you have to combine them, then you distribute, then you simplify, and then you have your second kinematic equation, which is change in position equals half of the quantity of initial velocity plus final velocity multiplied by time. Now you're going to combine your first and second kinematic equations.
Starting with the equation, change of x equals 1/2 times the quantity of at plus initial velocity times t. We can now add like terms to get change of position equals 1/2 the quantity of at plus 2vo times t. Then we can distribute the 1/2 and t to get the final equation of change of position equals 1/2 acceleration times time squared plus initial velocity times time.
Now we're going to show you how to use the kinematic equations and show your work. To show your work, we use a series of these steps. Step 1, list the givens and the unknowns. Step 2, choose an equation you are going to plug them into. Step 3, show your work with units. And step 4, show your answer with units. Step 1. List the givens and the unknowns. The givens in our problem are the change in position equals 100 meters, the time equals 5 seconds, and the initial velocity equals 0 meters per second. The unknown is the acceleration, which we are going to use. Step 2. Pick the equation you are going to use. The equation we chose was change in position equals half acceleration times time squared plus the initial velocity times time. Step 3. Show work with units. When we plugged the numbers into the equation, we got 100 meters equals half acceleration times 5 seconds squared plus 0 meters per second times 5 seconds. We simplified it down to 100 meters equals half acceleration times 25 seconds squared plus 0 meters per second times 5 seconds. We simplified again to 100 meters equals a half acceleration times 25 seconds squared, which then we simplified down to 100 meters equals 12.5 seconds squared times acceleration. We divided both sides by 12.5 seconds squared, which got us 8 meters per second squared, which is the acceleration. Step 4. Answer with units. The answer we got was acceleration equals 8 meters per second per second.
Now we have a practice problem for everyone to try. Using the equation change in x equals half velocity final plus velocity initial multiplied by time. A shoe falls out of a window. The shoe is initially at rest. The shoe is in free fall. It takes 3 seconds to fall 8 meters. What is the shoe's final velocity? The answer to the problem is velocity final equals 5.33 meters per second.